Hello. Today we will discuss the MRS, or marginal rate of substitution. The marginal rate of substitution tells us the rate at which we would substitute one good for another. In this case, we have a utility function such that we are Hello. Today we will discuss the MRS, or marginal rate of substitution. The marginal rate of substitution tells us the rate at which we would substitute one good for another. In this case, we have a utility function over goods 1 and 2. The utility function tells us how much happiness we get as we increase the quantity of each respective good. Since they're multiplying together, having more of both goods helps out our happiness. To find our MRS, the formula would be the marginal utility of x1 over the marginal utility of x2. Each marginal utility is the partial derivative with respect to that specific variable. For instance, the marginal utility of good 1 is 1/2 x1 to the negative 1/2 times x2 to the 1/2. Remember to keep that x2 as a constant. This looks very familiar compared to the other example that we used in the past, where it was just a function and we were taking the partial derivative. We put this over the marginal utility of good 2, which in this case would be 1/2 x1 to the 1/2 x2 to the negative 1/2. This time the x1 is held as a constant. While this formula seems a bit daunting, there's a lot of variables and numbers that we can cancel out. For instance, these 1/2s cancel out. This negative 1/2 signifies that we should change which side of the division bar this particular term is on. And the same is true for this negative 1/2. Altogether, when we make our adjustments, we end up with the function x2 to the 1/2 times x2 to the 1/2 over x1 to the 1/2 times x1 to the 1/2. Seeing as we have like bases here, we can add our exponents together due to the fact that we're multiplying. This means we're left with x2 over x1, seeing as 1/2 plus 1/2 is 1, and again 1/2 plus 1/2 is 1. That means our marginal rate of substitution for this utility function is x2 over x1. To help with interpretation, let's look at two different points. The first, we'll say, is where x1 is equal to 1 and x2 is equal to 1. In this case, we would have a marginal rate of substitution of 1 over 1, or 1. This means we're willing to give up 1 unit of x2 to get 1 unit of x1. Let's look at a different point to compare. What about the point x1 equals 2 and x2 equals 1? In this case, our marginal rate of substitution would be 1/2. This means we're willing to give up half a unit of x2 to get 1 unit of x1. So our interpretation will always be that we're willing to give up whatever our MRS is, amount of good 2 for 1 unit of good 1.